Hi, hello, welcome to another lesson of Secondary Math 2. We're going to be doing the final lesson of Unit 2, which is finding the inverse of functions. Alright, so during this lesson, you will learn how to find the inverse of a function algebraically and to be able to determine the restricted domain of the inverse of a function. Alright, let's get started. Vocabulary: f raised to the negative 1 of x. We say this as f inverse of x. This is the notation for the inverse function of x. An inverse is simply the opposite variable. Okay, so inverse functions are essentially the opposite variable, meaning that the inverse functions are reflected across the line y equals x. So x and y are going to switch from the original function. So the x and y's just change places. We know that a function is a relationship that maps a set of inputs to a set of outputs in which every input maps to exactly one output. That is also known as the vertical line test. Alright, the domain is the set of all first elements of a coordinate pair. We think of this as what x values exist within a function. A range is the set of all second elements of a coordinate, or the y values that exist in a function. A restricted domain. Sometimes we have to limit the domain, so we're only looking at a portion of the graph, so that the inverse will actually be a function. Sometimes when we take the inverse of a function, it creates something that does not pass the vertical line test. So we have to only look at a piece of it to look at the inverse of it. Alright, let's get started. Here we go. What is an inverse? We know that it's noted as f raised to the negative 1, or f inverse of x. And we know that it's reflected over the line y equals x. So to find the inverse of a function, we're simply going to follow these steps. We're going to switch the x and y values and then solve for the new y value. Okay, so let's do this. So f of x is just a fancy way of saying y equals 2x minus 8. My first step is just to switch that x and y. Those two are going to trade places. So I now have x equals 2y minus 8. Okay, so now I'm just going to solve for y. So I'm going to add 8 to both sides, and I get x plus 8 equals 2y. Then I'm going to divide both sides by 2, and I get x plus 8 divided by 2 equals y. Sometimes it's going to want you to write it as f inverse of x equals x plus 8 divided by 2. That is as far as I need to go. If you want to simplify it, you can say x divided by 2 plus 4, or 1/2 x plus 4. Any of those would work. Alright, I want you to try it now. Pause the video, take a crack at this, see what you can find. Alright, let's look at this. So my first step is to trade my x and my y. So I get x equals 3y minus 6 divided by 5. We're going to multiply both sides by 5. I get 5x equals 3y minus 6. Okay, we're going to add 6 to both of these. So we get 5x plus 6 equals 3y. Next, 3 is being multiplied by y. So I'm going to divide by 3, not by y. And I get 5x plus 6 divided by 3 equals y. Okay, we could write this as f inverse of x equals 5x plus 6 divided by 3, or 5x divided by 3 plus 2, or 5/3 x plus 2. Any one of those three answers would be the same. All right, let's try one more. Try this out. We have x equals y plus 3 divided by 4. We're going to multiply both sides by 4. We get 4x equals y plus 3. Then we will subtract 3 from both sides. And we get 4x minus 3 equals y. Write that as f inverse of x equals 4x minus 3. Ding, ding, ding. That is simply what we're going to do. Okay, so finding the restricted domain. So what happens when the inverse function does not exist? So we graph the function f of x equals x minus 1 squared. That is this red parabola right here. Notice my vertex is going to be at the 1, and then I have plus 0, so 1, 0. Right there, there's my vertex. So that's my original vertex. Okay, then when we take the inverse, remember when we take the inverse, it's reflected over the line x and y. So x and y trade places. There's my new vertex. So what we're going to look at here is, notice I have, when I take my my inverse, I get this green and blue parabola, and I'm going to get rid of some stuff so we're not clogged up here. Notice it's two colors. That's because you have to graph it separately because it's a new function. So if I take a line, notice it is hitting in two spots. So this tells me it does not pass the vertical line test. It should only hit once on a vertical line. Okay, so what we have to do is we have to look at just half of this, okay? I can either look at just the green half or just the blue half because I want my inverse to still be a function, okay? So what we have to do is we have to restrict our domain, which means I can either look at, so there's my vertex, I can either look at this half of my parabola, or I can look at this half of my parabola. So how we would state that is we could say, if I'm looking at that green half, I can say I only want to look at the domain when it's from negative infinity to 1. That x coordinate on that vertex, notice this is 1, 0. Or I could say from 1 to infinity if I'm looking at that blue portion of the quadratic. So I'm only taking half the quadratic, and it splits in half at that vertex. That's why I care about this equation right here and knowing where my vertex point is. Okay, so let's try this. Okay, so find the restricted domain of the following such that the inverse exists. So first of all, we know it's quadratic because I see that square there, okay? Next, I'm going to find my vertex point, which is, this is my x coordinate, so that's going to be a positive 4, it's always the opposite, and a negative 34, okay? Now, I really only care about that x coordinate because that's the piece that's going to talk about domain. Domains talk about x. So I'm going to say from negative infinity to a positive 4 is the restricted domain that I'm going to look at. If you want, you could totally go 4 to infinity. That one works too. Looking at the right side of the quadratic. Okay. All right. One more. Once again, I'm going to first find my vertex, which is a negative 5 and negative 4. Now I only care about that negative side, right? So we're going to say from negative infinity to negative 5. Negative 5 is included. Or from 5 to infinity. It is as simple as that. If you have any questions, please come and see me. Come find a tutor, and we would be happy to help you. Thanks for joining in for another exciting edition of Secondary Math 2, and we will see you in Unit 3. Take it easy, everybody.